This video will be a review of the overhaul of a cup and cone hub on a bicycle wheel. The cup and cone system consists of a cup-shaped bearing race, a cone-shaped bearing race called the cone, and ball bearings trapped in between. The system should be occasionally overhauled, cleaned, and greased to increase the life of the hub. Otherwise, over time, pitting will occur, and once that begins, it's only going to get worse. If you ride occasionally, an overhaul once every few years is fine. Cup and cone brands tend to share many commonalities. However, some models are going to have some special features. Always check with the manufacturer when in doubt. For information on overhauling the through axle hubs, see our other service video at our YouTube channel. This demonstration will feature a rear hub, but the basic procedures are the same on the front. After removing the wheel from the bike, remove the axle nut and washers or the quick release skewer. Then, time to remove the rotor to prevent contamination and remove the freewheel or cassette sprocket. Now for some preliminary inspections. Grab the axle and rotate it, getting a sense for the previous adjustment. Also feel for any pitting or grit you may notice. Could indicate problems inside. Grab either end and pull up and down, feeling for play. Also spin it and look for oscillation in the axle, both on the right and the left side. This axle has some oscillation seen on the left side. While this axle has oscillation on the right side. Neither axle can be repaired. Both of those axles would need to be replaced. Now to take the hub apart. As you proceed, it can be a good idea to take pictures as you go for orientation, should you not be familiar with the hub. On hubs that have a threaded axle that stick past the lock nut, it's a good idea to take the axle protrusion that's sticking out for later reference. Should you need to replace the axle or cone, that can be very helpful. A caliper, or you can even use a hex wrench to estimate here about 5 millimeters sticking past the lock nut. When possible, secure the wheel in an axle vise that's held in a bench vise. For rear wheel, secure with the adjustable side upward. That is the non-drive side. Tighten that on the axle. For a front wheel, secure with the adjustable side up, which will be the left side. Use the smallest cone wrench that fits on the cone and find the wrench flats. In this case, the combination wrench fits on top. Hold the cone wrench and loosen the lock nut counterclockwise. Remove the lock nut and notice the orientation that it came off. In this case, the teeth would face the frame dropout to get more bite. Stack the parts in order and continue to dismantle the spacer and then the cone. Another way to keep track of your parts is to use a small tie. We stack our parts in the order and orientation they came off. The thin washer, the lock nut in the correct orientation. We close the tie, we can clean it here, inspect it here. It can come apart when we're ready to put it back together. Carefully lift the wheel off the axle, noting that bearings may fall out. Have your hand under it. Bring it over to the workbench. Now we can look from above, count the number of bearings, and measure their size. Remove the bearings. Check the size. Turn the wheel over. Count the number of bearings. 1, 2, 3, 4, 5, 6. There's some gaps because some fell out. 7, 8, 9. Remove this side. Again, we measure. If they're the same size, same number, they can be mixed together. There can be press seals inside the hub shell. If they are difficult at all to remove, stop. These can be fragile and are easily damaged. These pieces are hard to find as replacement parts, so simply leave them alone. The same is true on this side. Leave it in place. Now remove the axle from the vise, and it's time to get set up for cleaning and inspection. Use a little degreaser, some brushing and wiping to get the parts that we removed clean. If the axle appeared unbent in the preliminary inspection, you can leave it together and clean it as it sits. The cone and its dust cap should also be cleaned. This particular cone has a pressed-on dust cap. We simply leave it in place. We don't try and unpress that dust cap. We'll clean inside of here to get any of that grit out of the way. Time now to get the hub shell clean. Inside is important, and also the outside. We want this to be a good-looking finished product for the person using it. Again, dust caps, if they come out, this is much easier to do. It's faster. Inspection is easier. But again, if those hubcaps are damaged, it's going to be very difficult to find replacements, and very difficult to align them so they're not rubbing again from being deformed. We'll clean off the outside with some soap and water. This side is the free hub. This side is important not to soak it with degreaser. We're not going to flush this. There is light oil inside the free hubs. So this is a hub bearing overhaul, not a free hub overhaul. Free hub service can be done separately, but for the axle bearings, the external cleaning is fine, and then an internal wiping, get the grit and old grease out. That is fine. We can even get inside. There we are. Now a more detailed inspection. Here is our axle. This is the side that was left together, the non-adjustable side. We can roll it along the edge of a bench and see this one looks pretty straight. That one's not a problem when you compare it to this one. Bent. Any oscillation is bad. This cannot be straightened or rebent. The axle will need to be replaced. Now, on to the ball bearings. After cleaning, the ball bearings should appear shiny and bright. If they're dull, they should be replaced. Ball bearings will trace a path along the bearing surface. You can look and also trace with the pick to feel any pits or wear. Here's the normal ball path from the ball bearings, but we can see and feel this roughness. Once this pitting is begun, it's not going to get any better. Cones are available as a spare part, but you'll need to match the thread, the cone height, and the profile. Also trace the bearing surface in the hub. This cup feels fine. With the dust cap in the way, it does slow you down. It is more awkward, but it can be done. If the bearing surface in the hub is badly worn, they're typically not replaceable. That hub will never adjust nicely. The hub should be replaced. If the axle is bad and needs to be replaced, the new axle should be the same length, but it can be a little longer as they can be ground shorter or cut. If the axle was replaced, after installing parts, remember to set the axle protrusion to your previous measurement. Mine was 5 millimeters if it was bad. My axle for this bike was good, but it's important to check the tightness of that lock nut against the cone. It's a double check, but it's an important one. If this was not properly tight, during adjustment, it's going to show up as a problem. We will hold the lower cone, take torque wrench to the top nut, 10 Newton meters. This one clicked right away. Well, it's at least 10 Newton meters. It's not stripped, so it's fine. The adjustment we're going to be doing on the other side is going to be the same, and it's going to be repeated quite often. So to learn that muscle memory will be good. We're going to take the 10 Newton meters and do it by a hand wrench to get that feeling set in our muscles. To do that, we're going to hold the cone again, break free the lock nut. Now, secure it with the torque wrench. There, released. We are at 10 Newton meters. Here, install the hand wrench and notice our angles. Hold the cone wrench, break free, and return that wrench to the same. That's what we're looking for, 10 Newton meters. Now we are ready to flip this in the axle vise and move on to the hub. Time to get greasy. Park Tool has two choices: HPG, high performance grease, and lower viscosity grease. Also, the PPL1 Polylube 1000. It's a thicker grease that actually makes packing the bearings easier. We're going to go with the HPG 1 in the grease gun for this hub. This one uses a labyrinth system on the dust cap. Not all hubs, but this one has a seal around the cone. It overlaps the dust cap, and that creates a seal. Consequently, a little bit of grease up inside the cover will create a waterproof seal when installed. We'll put that to the side. Now, to fill inside where the cup is and create a bed for the bearings. So we see down where the ball bearings go, and we do not spare the grease, because the bearings are going to sit in them and hold. Good. Even that up a little bit. 9 bearings came out of this side, 9 will go back in. Again, the bed that we've made holds the ball bearings as they go in. It is the oil that's in the grease that provides the lubrication. using a generous amount, we're going to have that oil around for a long time. We don't really know when we're going to get to see this hub again. Number 8, number 9, and then a double check, are they laying flat up in the cup? Not quite. There we are, laying flat. They're not jumbled. They're going to accept the cone once it goes in. Now we are ready to flip the hub. Repeat. Inside, healthy amount of grease. That will hold the bearings. If there's not a good, healthy bed for them to sit in, one could drop down into the center of the hub and cause problems later. So make sure we have the 9 that we started with. Seven. Eight. And 9. We don't really need to put grease on top. We already have a good pile of grease in there for them to sit in. This little extra on the top we're going to wipe off. And here's the cone with that extra overlapping cover we talked about. That's going to get a little grease in there to help with that seal against water. Now, for the axle to go in. In this hub, the drive side came out last, so it's going to go in first. We know that this security has been checked. It will be held in the axle vise. Drive side on first, which provides us some grease for the threads for the cone. Here, all of our pieces are tied together. In the orientation, they came off. The cone was first to go on. Thread it all the way down. Thread the adjustable side cone down until you can feel it contact the bearings. Right there. Stop. Next, from our bundle, we know this was next. And in this case, this larger washer was next. And last, the lock nut, again, in this case with the teeth, that would face the frame, the dropout, to help it hold securely. Now, to discuss the adjustment. The bearing adjustment on a cup and cone hub should be as loose as possible, but with no play or knocking when the wheel is mounted, ready for use. However, even at a correct setting, you may feel roughness as you turn the axle with your fingers. But remember, the wheel has far more leverage on the bearing surface than your fingers do. What you're feeling here is subjectively the bearing wear and the quality of the hub. That can vary widely. The adjustment procedures will vary depending upon the axle. The 9 and 10 millimeter threaded hollow axles for quick release hubs tend to flex when secured in the frame. Closing the lever on these hubs slightly increases the preload on the bearing. Because the adjustment tends to tighten a bit when mounted in the bike, your adjustment out of the bike should account for that. The solid axle hubs do not tend to flex as the quick release style. Also, the oversized quick release axles are not susceptible to this change. Adjustment of the wheel outside the bike and in the bike is effectively the same. Understand that bearing adjustment can be finicky. It can often take several attempts to get the bearings where you want them. Lastly, when checking for bearing play, only check when the lock nut is tight against the cone. The internal threads of the cone naturally have play against the external threads of the axle. That only goes away when the lock nut is tight against the cone. The cone wrench can be used to control the position and the adjustment. From our position here, that's a quarter turn loose. That's backed off the cone about 0.25 millimeters. From light contact, that would be about 1/8 of a turn loose. From light contact, 1/16 of a turn. Typically, that's a small enough increment in our hub adjustments. With practice, 1/32 is possible. That's a very fine increment of change. So to begin our hub adjustment, we are purposely going to start with no play. We're going to find that light contact right there. Hold the cone from turning and secure the lock nut, normal torque, about 10 Newton meters. With the axle vise, we can check for play, grab the axle and pull up and down on the wheel. Not surprising, there is no play here. In fact, it's probably too tight. To check for play without an axle vise, grab either end, pull up and down, alternating to feel for any play or knocking. Hold the cone, note the position again. Loosen the lock nut. I'm going to back off about 1/8 of a turn. Hold and secure. Again, hold the axle up and down with the rim. Still no play. I can go looser. There's my position. A slight amount looser. Repeat as many times as needed, checking for play only after that lock nut's tight. And here I feel knocking. There's knocking, felt at the axle. Definitely there's play. Now we can test this adjustment in the bike. With a small amount of play, time to test by loading it in the bike. We take our skewer and install. Do not install the rotor. Do not install the sprockets. If we're wrong, we still have more adjustments to do. We'll now install it in the bike. In fact, skip the chain. All we're doing is using these dropouts to apply pressure as if we're riding. We are fully up in the dropouts. We secure the skewer to normal riding pressure. Then we test. Grab the rim, grab the frame. Back and forth, side to side with the tire and the rim, and I feel for knocking. Nothing is showing up. The play that we had in the vise has gone away when loaded. The wheel is ready to go with sprockets reinstalled and the rotor reinstalled, back in the bike, good to go. If it's a customer's bike, they need to understand that the closing of the skewer is part of the bearing adjustment. It should be closed consistently and properly every time for their safety and for the bearings. Solid axle hubs tend not to change bearing adjustment when mounted in the bike. Begin the adjustment procedure similar to quick release with light bearing contact of the cone. Here is just where it's touching. But from here, we will back off a quarter turn, seeking to find play. Hold and secure the lock nut. Hold the axle up and down with the rim. We have knocking. We will now step by step proceed to remove the play. Hold, loosen. Slightly tighter, that 8th turn, hold, secure. Here, very, very slight amount of knocking. Hold the position, loosen the lock nut. We're going to try a very small amount, stop, and I will secure. Rotate the wheel around to different positions. That should be the loosest setting without play. It's not going to change within the bike. Solid axle is done. With bikes that use a cup and cone system and a quick release skewer, it's possible to do bearing checks even with the bike fully assembled. Here, we check for play by grabbing the top of the rim, pulling it side to side, feeling for a knocking sensation, which we have here. Next, check the security of the quick release. In this case, that is set quite loose, unsafely so. Here, let's tighten up the skewer to a proper setting. We're getting resistance about halfway through the swing. It fully, that's tight. Check again. In this case, the bearing play is gone. This is an adequately adjusted front hub. Here's a wheel we haven't worked on. It's possible to do the bearing check with it still installed in the bike. Grab the frame or fork, grab the top, pull side to side, checking for bearing play. No knocking here. Could be that's a good bearing adjustment. It's possible it's too tight. To know the latter, we're going to relax the skewer as a check if it's tight as well. It does seem properly tight. There's resistance. We partially open it, not all the way, partially opened. We've relaxed the preload. I check here, still no bearing play. We would normally expect some. Potentially, that bearing adjustment is too tight. We would need to remove it from the bike to fully check. Thanks for bearing with us as we knocked about cup and cone overhaul. For more videos on hub service, see our Park Tool YouTube channel.